Okay, refer to given here. Look at this one. So we have the Mr. Lee built stair in the garden. He used 8 brick on the first level. For each subsequent level, he increased another 8 bricks. The total number of bricks used on each level can be written in progression. So we have 8, 16, 24. So if we look at this sequence, we have 8, 16, and 24. Actually, we have the pattern. So this is we call as a progression. Okay, 8 as the first term, so we will label as T1. Okay, first term we will label as T1, second term we will label as T2, and so on until the end term. The end term we don't know if we want to find a fifth term or 20th term. So we will label the nth term as Tn. Okay. So next, in progression, we have two types of progression, which is we call as a arithmetic progression, and another one is geometric progression. So So in sequence, so let's say we have sequence 2, 4, 6, 8, and so on. So another one we have 2, 4, 8, 16, and so on. So this is we call progression. And the first one we call as the arithmetic progression. Arithmetic progression. And the second one, this one, arithmetic. This one is geometrical progression. Okay. So why? We look at the pattern. So we have the first one, we have 2, 4, 6, 8. So means here the pattern we add on 2. Okay, we add on 2, add on 2, add on 2. So means this when we using the addition, so we will call it as a arithmetic progression. So look at second pattern, second sequence. So we have 2, 4, 8, 16. So means here this pattern will be times 2, times 2, times 2. So this is we call geometric geometric progression. Okay. So when we use addition, we call as a arithmetic progression. And when we use multiplying, so we call this one as a geometric progression. So next, we want to do example 1. So let's refer to example 1. Example 1. So here we have the example 1. Determine whether each of the following sequence is arithmetic progression. So we want to check whether these both we have the sequence A and B. So it is in arithmetic progression. So how to check whether the sequence is in arithmetic progression or not? So we will check. Okay, we will check common difference. So what is common difference? So if we have 2, 4, 6, 8, and so on. This is arithmetic progression. So this is we call as a T1. Okay, this one is a T2, T3, T4, T3, T4, and so on. So this is T1, T2, T3, T4. This T1, we call it as A. Okay, A as a first term. Okay, first term is A. Then the pattern between 2, 4, 6, 8. Different 2, 4, 6, 8 here. The pattern is 2 at 2. So this is we call as common difference. So the value 2 here must be same until the last sequence. Okay, that one is about what is common difference, what is the A, what is the first term. So next, for this question, we have 358, 350, 342. So we want to find the common difference here. So common difference here, we will check between this one and this one, this one and this one. So how to check? We will use T2 minus T1. 3T, T3 minus T2. So we check whether they are in a same same number, same value, the common difference for each different here. So we want to check T2 minus T1. So T2 here is 350 minus 358. Okay, so 350 minus 358. So we get negative 8. So next we check between 342 and 350. So 342 minus 350, we get negative 8 also. So it means here this sequence is arithmetic progression because we have the common difference here, negative 8, negative 8. So to find D, how to find D? So we will use Tn minus Tn minus 1. Means here we use the term minus with the term before. Okay, to find D. So this is the first method to find, not method, this is the first formula in arithmetic progression. So next question B. We have 2 over 3, 2, 10 over 3. So we have to find D. So to find D is Tn minus Tn minus 1. So if we use T2, it will be T2 minus T1. If we use T3, so it will be T3 minus T2. If we use T4, T4 minus T3, and so on. Okay, it repeated lah, using the formula to find the common difference. So here we have 2 over 3, 10 over 3, and 5. So let's check D1, D2, D3. So we check this one first. So how do we check? We will use T2 minus T1. So T2 is 2, T1 is negative 2 over 3. So we will get 4 over 3. Then 10 and 10 over 3 minus 2. So 10 over 3 minus 2. So we get 4 over 3. So in a common difference. So let's look at 5. So 5 here and 10 over 3 here. So we minus, we find D3. So 5 minus 10 over 3, we get 5 over 3. So if we look at here, so this is 4 over 3, here 4 over 3, here is 5 over 3. This is not common, this is not same. So means here, this is not a progression. So until here, can you understand?
Yes, teacher.
Okay, thank you. So next, we want to continue. Okay, we want to continue in arithmetic progression that I said before. We have two types of progression, which is arithmetic and geometric progression. So for today, we will discuss the arithmetic progression first. Okay, So let's look at page 131. Okay. Okay, in aromatic progression, we have two, we only have two formula. Okay, two things to find. First one, we want to find the term. Okay, first one, we want to find the term. Another one, we want to find the sum of sequence. Okay, sum of sequence. So we have two type of formula. Term in aromatic progression, you can take note as a Pn equals to A plus N minus 1 D. Okay, Tn equals to A plus N minus 1 D. So this is for term. We want to find the first term, we want to find the third term, fifth term, or 20th term. So we will use this formula. For another one, okay, another one, the sum of sequence, we will use S n equals to n over 2a plus n or minus 1 d. Okay, so this is sum of sequence. So what is A, what is T, what is N? So the first one here, when we want to find the term, the value of term, so A plus N minus 1 D. Okay, so A is the first term. Okay, A is the first term. Next, N. N is the term. N term lah. Ke berapa awak nak cari? So next, D. D is a common different. So here, in arithmetic progression, we will use these two. So nanti akan ada satu lagi lah. We have another one formula from this sum of term. Produce another new formula. So let's discuss first the nth term. So we want to find the nth term. So look at example 3. Okay, here is the example 3. So we have example 3. Find the term for arithmetic progression -4, 2, and 8. So -4, 2, and 8. So we have to find 15 term of arithmetic progression -4, 2, and 8. So given here -4, 2, and 8. So we can find this is A. So D we need to find. So how to find D? We will use T and minus, Tn minus Tn minus 1. So the the second minus first, third minus second. So here given is arithmetic progression. We no need to check whether it is progression or not, because already given in the question, this is arithmetic progression. So it must have common difference. Okay. So we have A is, sorry. So we have A negative 4. So then to find B, we use 2 minus negative 4. Okay, so we get D is 6. So next, we want to find 15 term. Okay, 15 term. So we will use the formula Tn equals to A plus N minus 1 D. Okay, so A here is negative 4. And here is the 15 terms of 15 minus 1. Then D we get 6. Then we will find the value which is 80. So this is to find the nth term. So next we look at question B. Okay, question B, we have negative 6, 5 and 16. So negative 6, 5 and 16. So A, what is A? The value of A, anyone?
-6.
Okay, thank you, Yasmin. So negative 6. So how about D? So we will use 5 minus negative 6. So 5 minus negative 6, we will get
11.
11. Okay. So we have A, we have D. The question asks me to find 24th term. So our N is 24th. So Tn equals to A plus N minus D. Okay. A is negative 6, N is 24, minus 1, and D is 11. So we will get negative 6, 24 minus 1, 11. So we will get 247. Okay, clear? Any question until here?
No, teacher.
Okay, thank you, Santia. So next we want to proceed. Question number 4. Question number 4. So given that an arithmetic progression with the first term is negative 6, the common difference is 11, and nth term is 1 to 6. So we want to find the value of nth. Means here what we have here, the information given, we have this is arithmetic progression. Okay, make sure we need to check the question, what the question give, what is the progression, what type of progression given. So sometimes question give arithmetic progression, sometimes it will give geometric progression. Now we follow the chapter, means here everything will given as a arithmetic progression. So given that an arithmetic progression, first term is negative 6, so this is the A. Then common difference is 11. So here is D. And next, nth term. So we don't know the nth. So, but we have the Tn value which is 1 to 6. So from the equation, okay, from the formula, we have Tn equals to A plus N minus 1D. So our A is negative 6. D is N. N we don't know yet. N minus 1. And D is 11. But we already have Tn here. The value of Tn is 1 to 6. Okay. So we have 1 to 6 equals to negative 6. N minus 1 times 11. So solve this right hand side. And we find that we use the linear equation. We will get N equals to 13. So this is concept of arithmetic progression. So we want to continue to the sum of first and term. So turn to page 138. So in page 138, we have sum of first term, which is we write as S, and then the formula given. Okay, the formula given as n is equals to n minus 2, 2a plus n minus 1b. Okay, so this is sum of arithmetic progression.
Teacher, what page?
Page 13, oh sorry, 133, 138 lah.
Okay, teacher.
Okay, thank you. So next we want to check. Okay, we want to do example 6. Yeah, sebelum tu in page 134. So we have in above. So we have another formula given. So we will discuss later that one. So we will check. We will use this formula first to solve example 6. So let's do example 6. Example 6. Okay, so look at example 6. Given the n arithmetic progression 4, 7, 10. Okay, so we have A, we have to find D. D, 7 minus 4 is 3. Okay, then we want to find the first sum of first 35 term. This one, this word, the first 35 term, we will discuss later. What is the first, what is the next? Okay, so we have we have all the value A, N, and B. So we can use the formula Sn minus Sn equals to N over 2 times 2A plus N minus 1 times D. Okay, so Sn equals to n over 2 bracket 2a plus n minus 1b. So we will substitute all the value. N is 35. N is 35. Then A is, apa tadi? A is 4. And 35 again. And D is 3. So 35 over 2. 35 over 2, 2 times 4, 35 minus 1 times 3. So we will get the sum of the 35 term is 1925. So means here we add from A until T35. So kita tambah semua, add all the value in a sequence from A until, from T1 until T35. Okay, so kita tengok contoh lebih ringkas. Okay. So we have Sn, okay. If we have, I want to tell about first term. So we have 2, 4, 6, 8, 10, 12. Okay. First sum of first 3 term. Sum of first 3 term means we will use 2, 4, 6. Okay. The first three terms is 2, 4, 6. So we will add 2, 4, and 6. We will get 12. Okay, this is the simplest progression, the simplest pattern. So just to show the example. So next, if the question gives first sum of first three term after third term. So which term we should add? Sum of first three term after third term.
8,
Any idea?
10, 12,
8,
10, 12.
10, and 12. Yes, good. So first three term after third term. So this is third term. Then the first three term after third term is 8, 10, and 12. We will add 8, 10, and 12 here. So this is why we use the first n term, that one. So here we want let's continue example 6b, the sum of the first n term. So the first n term uh, so we use n as a n term, okay, as n term here. So next we use 2a. A is 4. Next n minus 1, and also we don't know yet. Then 3. 3 here is as a d. 7 minus 4 there. So we will simplify everything. So this is the formula for this equation only. Okay. So when we want to find Sn, it will be n or minus 2, n over 2 times with 5 plus is 3n. So here is from the sequence given. Okay. So next example 7. Okay, we want to discuss example 7. So in example 7, the sum of first term of an arithmetic progression is 230. Mana dia? Salah. So the sum of the first 10 of arithmetic progression is 230, and the sum of the subsequent 10 term is 630. So find the first term, A, that common difference for this arithmetic progression. So the first term, okay, the first 10 term, it will be T1 until T1 until T10. So next, the subsequent 10 term will be T11 until T20. So this Sn will be get 230, and here T11 until T20, the sum is 630. So then, so we will use the Sn10. Okay, we want to find S10. So 10 over 2, 2a, we don't know yet 2a, 10 minus 1, b. So S10 we have 230, 5, 2a plus 9b. Okay, so this is for S10. So for S20, we find S20. So will be 20, 2A, 20 minus 1 and D. D pun kita tak tahu kan. So given di sini hanya sum of 10th term, the first 10 and then subsequent another 10. Okay. So this one is not equals to 620. S20. To find another subsequent, this 630 is S20 minus we S10 because we have T until S20 is T until T20. So we will do this one. 230 plus 630. Okay. So is equals to 10 2A plus 19B. Okay. Ini ambil dari mana? Here. Here is from S20. So S20 is 10, T1 until T2, T10, T11 until T20. So this is T1 until T10, this one T11 until T20. So this is S20. Okay, so this one plus this one, we get S20. So we can find the value of A and D by using the simultaneous equation. So this is, we have the S10. So then the second one from the S20. So we can get D. We also can get A actually. Okay, ada kan? Tak habis ni. Yeah. So, any question?
Teacher,
Mm-hmm.
like sum of the first 10 terms is this said T1 to T10, isn't it, teacher?
Yes, okay.
So they put N as 10
Yes,
for
okay.
okay. So for the second one, the sum
Mm-hmm.
of the subsequent in 10 term, why they put 20? Why didn't
No,
put
this one is not the next subsequent. This is total from T1 until T20. That's why use S20.
we cannot choose 11 or 12 others, teacher.
If we use 11, 12, okay, look. If we use 11 until 12, so we have the T1 until T10. So this is the S T1 until T10. So we plus we will get S10. So then we have T11 until T20. So here, if we label this one as T20, so the A must be start with T11. Did you get the answer? The concept. A must be start with T11. But here now we don't know what is the value of T11. Clear? So that's why we use the sum of from T1 until T20, which is, this is 230 and this is 630. So which is, we use S20. So A is the same, A here. Um, and here we will use 20 here. Yeah?
Clear, teacher, clear.
Okay. So any question? Yeah. So next, look at, okay, tadi saya kata in page 134. So in page 134, we have in above, we have Sn equals to n over 2 bracket A plus Tn. This is from where? This is from where? So, so this is another formula. Okay, if the basic formula T for sum of term is n over 2 plus a plus n minus 1 d. Okay, n minus 1 d here. So let's say uh, this one as a tunjuk macam mana? Oh, yeah. So if the Tn is the last term, okay? If the Tn is the last term, we will use for Sn as n over 2 bracket A plus L. L here as the last term. Okay? So soalan ada jumpa tak soalan? Saya tak jumpa lagi soalan. So bila jumpa nanti kita akan bincang. Okay? So this is another terbitan, another new formula from the SN, the original SN. Okay? So if we have the last term, we will use n over 2a plus L. So this is I will give you what exercise to do in page 138. Page 138. So page 138, question number 1, 2, 3, 4 and 5. Can you banyak tak homework awak hari this week?
Teacher, repeat.
Page 138, intensive practice 5.1. So question number 1 until number 5. 1, 2, 3, 4, 5. All question. Is it too much?
Okay, jam.
Discount teacher. Zulaika minta discount. So to banyak ni. Kan lah.
Okay,
Okay So Zulaika pelan-pelan buat sebab we have Saturday until Monday. Okay kan? Okay. So you will do your practice. We'll be here until 9:30. Okay, so for those who didn't mark attendance yet, so this is the link. So you can mark attendance, and for the rest, you can leave the meeting and do our practice. So thank you.
Thank you, teacher.
Welcome. Okay, welcome. Welcome.
Thank you, teacher.
Welcome. Hi, Masha. Yes? Any question? Yes? Get the link. I just give it to you just now. Okay. Welcome. Yes, Penny.
Teacher, are you there?
Yeah, I'm here. Yes, Sabrita.
Teacher, I need help on logarithm.
Oh, logarithm. Of course, can. Which question?
Teacher, on page 119, I don't understand.
119. Example lah.
Yes, teacher. And then you gave exercise for self-practice 4.13. I do not know how to do that because I don't understand the
Okay. Never
example
mind.
on page 119.
Okay, let's discuss. So in example 32, so given here is 3x minus 4. Dah salah guna ni. Okay. So we have 3x minus 4 equals to 5x minus 3. So we have 3 in the left side and 5 in the right side, and also we have the index for both sides. So we will add on log for this equation to make it the power become bring to the in front. So we will add with a log. So actually we can use any log of base. So but better we will use log 10 because in our calculator only have log 10 and log e. So log e is for ln, log. Okay, so we have we add log 10 log base 10 3x minus 4 equals to log 10 5x minus 3. Then
Teacher,
we will, yeah,
teacher, the 5 is 50.
oh sorry, thank you, 50. So log 10 50. Okay, so after we use the log, we can bring this power to in front because the basic law of log. So we have x minus 4 log 10 3 equals to x minus 3 log 10 50. Okay, until here.
Okay,
So
teacher.
x minus 4 here, we will times with this one. Here also we times with this one. Okay, x minus 4 times log 10, 4 times log 10. Same also, this side, x will time with 10 log 10, negative 3 also times with log 10. So we will get, okay, in the left side, x log 10 3, okay, x times with log 10 3, so we get x log 10 3 plus minus this one minus plus minus 4 times log 3 we will get minus 4 log 10 3. This is in the left side. So in the right side, x times log 10 50, so we will get x log 10 50 and negative 3 times log 10 50, negative 3 log 10 50. So until here, okay?
Teacher.
Okay. So next, we have x in the left side, x in the right side. So this x term we bring to the left side, and the value term means we don't have any unknown here, we will bring to the right side. Okay, so it will be x log 10 30 10 3, and we bring this one to the left side, it will be minus x log 10 50. Then negative 3 log 10 50, this one. And the other one, negative 4 log 10 3 will be positive 4 log 10 3. That much. Positive 4 log 10 3. Okay, so we have x here, x here. So we can factorize. We take out the x. So when we take out the x, it will get x log 10 3 minus log 10 50. Okay, until here okay. Yang ni salin balik lah. Copy back. Okay, next. We have this one. So, in the left hand side, we have this one. So, we have x. We want to find the value of x. So, we leave x in the left side. And we bring all this one to the right side. So, the relationship between x and the bracket is times. So, bring to the right side, it will be divide. So, next. The right side, the left side will be x. Then the right side will be negative 3 log 10 50 plus 4 log 10 3 over, okay, we bring from the left side, we will get log 3, log 10 3 minus log 10 50. So this one we will use calculator. Okay, we will use calculator. Log 10 50 berapa? Then log 10 3 berapa? Then find the value. Negative 3 log 10 50 plus 4 log 10 3 over with log 10 3 minus log 10 50. So soalan dia bagi dalam in your textbook, you won't direct get the answer, but better you use step by step. Okay. Sebab nanti awak salah masuk dekat divide ni, awak dah tersalah. Dia akan jadi only this one and this one divide. So better do the up one first, then followed by the bottom one. Okay.
Okay, teacher.
So we will discuss example 33 next.
Can, teacher.
Okay. So for example 33, we have given ln for x minus 2 equals to 5. So ln here is log e. So please remember when we use ln here is log e. So let's use the log e. Log e, log base e for x minus 2 equals to 5. Okay. So this is in the form of log. So we have the e. So we have all the value actually. So we can find x. So by using e, this is the base, change to index form e power of 5 is equal to 4x minus 2. So e here you can press your calculator. E5 here is 148.4132 from your calculator. E5. Use the E5. Then equals to 4x minus 2. Then we can find x by using the linear equation. Bring the negative 2 to the other side and also 4 to the other side. So we will get x is equals to 37.603. Clear? Can I request for recording? I don't have internet, have problem only. Yes, I'm still recording. I will share the link after. Okay, Penny? Okay. So next we discuss B. 10 e power of 2x equals to 35. Siapa tadi? Saprita. So okay, now A, question A.
Yes, teacher. A, okay.
Okay, so we continue to second question. 10 e power of 2x equals to 35. So we have 10 e 20x. So we will use ln e. Okay, ln e. Before that, we bring this 10 to the right hand side. So we have e 2x equals to 3.5 because we divide that. So e here we will use log e better because we already have the e. So better we use log e. E 20x is log e 3.5. Okay, so this index will become 2x log e equals to ln 3.5. Why ln? Because log e is ln. Okay, so next log e is the base and this value same, so it will become 1. So 2x times 1 is 2x. 2x is equals to ln 3.5. Then x here ln 3.5 over 2. So use your calculator, press ln 3.5 over 2, so you will get the answer 0.626. Okay, Saprita. Clear?
Okay, teacher.
Okay. So you may try the exercise. So you will ask me if you have any problem.
Okay, teacher, thank you.
Okay, welcome. Okay, Bapa Penny. Dah keluar Penny.